Welcome everybody to today's SPE Live webinar on the topic of We Are Delivering the Energy Transition Through Hydrogen and CCUS. I'm Mike Smith, I'm the CEO of NECCUS. And NECCUS is the Industry Association for Industrial Decarbonisation here in Scotland. We have about 50 industrial organisations as our members, and they represent the vast majority of the emissions from industry across Scotland as a whole. And I'm joined today by three excellent panelists. If I could start by introducing Suzie Ferguson. Suzie is the carbon capture technical lead in Wood's specialist engineering and consulting team, and has been working on CCUS and decarbonising projects for 13 years now. Most recently, Suzie's been working across a number of low carbon industrial cluster projects, including Humber Net Zero and Net Zero Teesside here in the UK. I'll now introduce Charlotte Hartley. Charlotte has been with Pale Blue Dot for over 5 years and is currently the Stakeholder and Communications Lead for the Acorn CCS and Hydrogen project. Charlie has also recently been a member of the Scottish Just Transition Commission and the IPPR Environmental Justice Commission. And our final panelist today is Martyn Tulloch from OGTC. Martyn is a chartered engineer with over 20 years of experience in both the oil and gas and the renewables sector. The energy system integration team that he leads in OGTC covers 3 industrial sectors that offer huge growth potential for the energy transition, those being offshore renewables, hydrogen, and CCUS. So if we start our panel session, and firstly, it's important to recognize that the time for talk has passed when it comes to CCUS and hydrogen. We're now in the phase where we need to deliver the energy transition through these important energy vectors. So if we could, let's start by thinking about the impact that those vectors can have on the energy transition. And I'll maybe start, if I can, with a question to Charlie. So Charlie, how much impact do you think CCUS and hydrogen can have on the journey to net zero?
Thanks, Mike. Well, my opinion is biased, but I think that they can play a really critical role in our journey to net zero. The Committee on Climate Change have said that CCS is essential, not optional, for meeting our net zero targets. And Paul Wheelhouse, the former Scottish Minister, has highlighted that Scotland has all the ingredients in abundance to create low carbon hydrogen, either from blue hydrogen from natural gas or green hydrogen from renewable energy production. So yeah, in short, a very, very critical part that we can play using CCUS and hydrogen technology.
Okay, and maybe I can follow up. Do you think there are particular parts of the economy where it could have the most impact?
I think what's really interesting is like what we're seeing generally across the energy portfolio is a lot of the easy to decarbonize parts of the sector being decarbonized through renewable electricity, which is great, and we need lots more of that. But the real place where CCUS and hydrogen can have a real role to play is in the harder to decarbonize sectors, places where it's difficult to abate emissions in another way. So for example, petrochemicals, where hydrocarbons are a feedstock. Our national gas transmission system is obviously using natural gas. And how do we decarbonize that? We've already got such a significant amount of pipeline infrastructure in place for that. How do we best redeploy that for a low carbon technology? So yeah, I think that the role that CCUS and hydrogen will play is really in the difficult to decarbonize in other ways sectors. So that's predominantly industry, heat and transport.
Okay, thanks, Charlie. And certainly as NECCUS, we've seen the same thing. You know, some of the important commodities that our society depends on, you know, the cement and the bricks that build our hospitals and our houses, you know, the pharmaceuticals, you know, the steel that builds our bridges, they all need CCUS and hydrogen. So I think I'd agree with you. If I maybe move on to Martyn, you guys at the OGTC have done quite a lot of work in the last year or two covering both the onshore and offshore impacts of the energy transition. how do you think that we can integrate the onshore and offshore ambition for this move to net zero?
Yeah, that's a really good question, Mike. I think the offshore is going to be absolutely pivotal in the UK, since especially, if you look at the numbers, we're quite fortunate in the UK to have the Climate Change Committee give us some strong guidance on what we need to do to get to net zero. And depending on which scenario and how much blue hydrogen is in the mix, we could need between 75 and 175 megatons of CO2 storage capacity each year. So if you look at that in a project scale, that's roughly between 20 and 30 projects for that central case. If you look at the capacity in the North Sea, it's 78 gigatons. Now, the vast majority of that is saline aquifers, but there's also disused oil and gas fields. So potentially over 300-400 years worth of storage capacity. And that's before we start to look at the Northern Lights type project where we could import CO2 from Europe. And that's something that we're actively looking at. So I think to summarize, we feel that the offshore infrastructure, the offshore pipeline network could be absolutely crucial. Also, quite often overlooked is that hydrogen storage requirement. So there's a huge swing in demand between winter and summer gas demand in the UK. And the rough numbers are roughly 1.5 terawatt hours per day in summer and more than twice that in winter. So hydrogen is the only technical option that's got that capacity. Things like compressed air storage and pumped hydro storage can give you that sort of week to month-long capacity, but not in big enough numbers. So we really feel that reusing the infrastructure and reusing the skill set in oil and gas is going to be absolutely pivotal.
Okay, thanks, Martyn. And I think you've raised a really important point about, there's not just the issue around seasonal changes in the demand, but also, what can we do to ensure that the infrastructure that we build for hydrogen and CO2 can meet the potential eventual demand, not necessarily just the initial demand that we might see in the next 5 to 10 years.
Absolutely, and that's where scenario planning is going to be crucial. If you look at the next 10 years, realistically, we may see 2, 3, 4, maybe 5 pilot and early commercial projects. But it's only from 2030 onwards that both CCS and hydrogen really come into their own if you look at all the build profiles. So I think it's essential for us to work across industry and also quite importantly across borders. So with our colleagues and potential partners across Europe in particular. Okay.
And and I think we'll come back to that collaboration issue towards the end of the debate today. Another area that is discussed extensively with regard to CCUS and hydrogen, and indeed the energy transition as a whole, is the focus on technology and innovation. So maybe again, Martyn, if I can come back to you. OGTC has shown a lot of leadership across the North Sea in regard to technology mapping. What do you think the potentially disruptive technologies could be in the CCUS and hydrogen space?
Yeah, we've been fortunate, Mike. We've had a lot of strong input from industry in workshops and one-to-one sessions to help us shape our technology roadmap. And we focus on two things, both making incremental improvements to existing technology, but also, as you mentioned, looking at the next generation, the potentially disruptive technologies. It's important to keep an open mind. We don't know the answers, and it wouldn't be disruptive if we knew what they were. But in terms of existing technology, I think there's a couple of really interesting projects out there. Wood have got a really good piece of technology looking at an enhanced SMR process where they recirculate some of the waste heat. Linde have got an equivalent of enhanced process. But looking for disruptive technology, I think in terms of blue hydrogen plasma generation, it's got a really interesting few years ahead of it. There's a number of startups looking at that. That produces carbon black as an end product rather than CO2. If you use renewable power, it could be potentially zero carbon. And then in the electrolyzer space, we've actually got two quite interesting technologies in OGTC that have the potential to be disruptive. One of them is looking at a supercritical electrolyzer. So that's using higher temperature, higher pressure fluid. And the other one's looking potentially at using seawater as your medium for electrolysis, against getting rid of that desalination step. But in reality, there's so many interesting startups there. There's so many technology development projects that the next 2-3 years are going to be absolutely fascinating to be involved in.
Yeah, I think you're right. And I guess, are you seeing any issues with getting some of those new technologies adopted at at least a demonstration scale? I mean, there's we're moving into large scale projects moving forward in terms of both blue and green hydrogen and CCUS. Is there a challenge in terms of getting that technology that is slightly lower levels of TRL adopted and utilized, or do you think that as long as the cost benefit is there, industry will appreciate that as a fundamental driver for growth in this area and embrace those new technologies wholeheartedly?
Yeah, one of the most important roles we play in OGTC is nothing to do with our funding, or it's more to do with joining people together. So for me, one of the challenges is to join the technology development community together with the academic community, and then the ultimate end users, people like Charlie's Pale Blue Dot. So that is something that we try to do actively. We've got a program now focused on low TRL technology that ties universities and startups together, and that is funded via Scottish Government funding that we're extremely grateful for. But we need to expand on that. We need to fail more as well, Mike. With technology development, you need to learn from your mistakes and incorporate that in the next generation. So that sort of sandbox mentality, everybody working together, is going to be really important.
Yeah, no, I agree, and I think that area of sort of trying fast, if needed, failing fast, and learning from those failings is going to be really important. And an area where I see rapid innovation and potentially that being embraced more than anywhere else is on CO2 utilization. The idea that you can take some of the CO2 stream that you captured and use it to make feedstocks or other products that are useful in society. What do you see as some of the opportunities in that carbon utilization space? What are the attractive technologies, and do you see any challenges in that area?
Again, looking at our roadmap, we're focusing heavily on synthetic fuels. I think that's technology that's going to be crucial to get to net zero. We need to be able to decarbonize aviation in particular. But outside, there's so many options, Mike. As you know, there's materials, there's feedstocks, there's proteins. Rice University in Texas is doing some really interesting work looking at graphene and using that as a building material and potentially as a fabric. So it's an area we're just starting to explore at the moment in OGTC. If you look at our Closing the Gap report that we published last year, it gives a full sort of overview of the multitude of options out there. I think from a Scottish perspective, it's going to be really interesting to see what happens at Grangemouth. Again, that's going to be a really important part of the ecosystem over the next decade for us. But no, our main focus is on synthetic fuels. We've also got an interesting project that I almost forgot to mention, funded through the European Union. We're working with a Dutch startup that's got a carbon utilization technology that produces formic acid. Again, another industrial feedstock, low TRL at the moment, but we're working in partnership with around about 20 partners to try and commercialize that.
Okay. No, and I think as NECCUS, we think CO2 utilization's got some really interesting potential. It could be a way of monetizing some of the costs of carbon capture, which is going to be important. But also, particularly as you highlighted, some of the biological CO2 solutions, really, other than waste heat and a CO2 stream, they don't require an awful lot more. Nature takes its own lead, and there's an opportunity, I think, there to do more. And certainly in Scotland, we have a massive aquaculture economy. We have a big economy around, obviously, world famous for Scottish beef. There's opportunities for fish meal, for feedstock, for livestock, which I think could be really attractive. For those of you who are kind of having a little bit of trouble wondering where Suzie is, she's having some issues joining us, so we will definitely get the opportunity to talk to Suzie once those have been resolved. I was going to ask Suzie about some of the technology that Wood are developing, but we'll make sure that we get the chance to do that. But for now, I'll maybe ask a little bit of Charlie. Obviously, Pale Blue Dot are leading a whole suite of projects, the Acorn suite of projects. Where do you see the balance on those projects that are probably, in the UK at least, some of the most advanced, the closest to being sanctioned? So where's the balance between current and new technology? in a suite of projects like that?
It's a good question. At the moment, honestly, we are planning and currently working on the basis of deploying technology that is already proven. So, of course, there are several carbon capture and storage projects operating worldwide, and there are several hydrogen production facilities operating worldwide as well. And in order for Acorn to be able to proceed and operate at scale and at pace in order to meet their kind of UK net zero targets, and we are aiming to be storing between 5 and 10 million tons of CO2 by 2030. We have a bit less room for experimenting with new technology at the moment, as we just kind of focus on really getting our project up and running. Having said that, we do really support the development of new technology, and there's such a major space in there for it. I always say that, you know, carbon capture and storage is kind of what we consider to be a really great way to decarbonize at the moment, but in 50 years there could be something different, just in the same way, you know, 50 years ago oil and gas addressed a certain challenge, and now that we've got a different challenge with different technology solutions coming to the fore. We are working with the likes of kind of direct air capture technology providers, so we're working with Carbon Engineering. So of course that is a relatively new technology. Generally speaking, we're finding that it's much more mature elsewhere, particularly in the USA, than it is in the UK. And the challenge is actually getting everyone in the UK up to speed with the developments which are happening elsewhere. And then there's the likes, which Mike, you may be able to speak to as well, about the likes of like IDRIC, the Industrial Decarbonisation Research and Innovation Centre, which is the kind of perfect centre and kind of test bed for trying to get a lot of the projects and technology solutions which are in their research stage, like rapidly up the technology readiness levels, so that they can be built in as a module to, whether it be Acorn in the Scottish cluster or Teesside, Humberside, wherever it may be, and trying to de-risk and accelerate their development in a non-commercial project so that they can be kind of plugged in and working at scale.
No, I think this challenge of taking these new technologies, advancing them through the TRL levels to a point where they're at a sort of a demonstration scale is critical. And I think groups like IDRIC, but also most the US and Canada also have sort of national level champions around this topic. But I think even beyond that, you've then got the challenge of, from a demonstrator level, how do you get it on a commercial scale? And again, I think that's an area where there's probably going to need to be quite a lot of funding support for that first of a kind commercial level projects, because there is significant risk in these more novel technologies, and whilst there are much less risky technology alternatives, it's something needs to bridge that gap. Otherwise, my worry is lots of things have been demonstrator scaled, delivered, but very little has been done on a commercial level. Well, then I guess that leads us neatly into the next thought, which is, obviously to deliver the energy transition, we require the projects that are being moved forward today to be replicated and expanded upon, and for that to be done as rapidly as possible so that we can address the climate emergency. So maybe if I ask each of you in turn, which energy transition projects do you think can be scaled up and replicated, whether it's in the UK or beyond, and that ultimately could make a major impact on the delivery to net zero? Again, maybe Charlie, if you want to talk a little bit about some of the things that you're seeing from the work that you're doing in Acorn, and then I'll come to Martyn. Yeah,
of course. And I think the short answer is, which project do I think is the most scalable? And I'm inclined to say the one I work on every day. So what we are looking at and where we see the real opportunity for scaling our project is with shipping, with importing CO2 by ship into the Peterhead port, which is very near where our storage site will be located, to really kind of utilize our natural asset, which is a significant CO2 storage potential in the North Sea, with the fact that we comparatively don't have that many CO2 emissions in Scotland, but there are elsewhere in the UK and around the North Sea Basin which have the opposite problem, where they have a lot of point CO2 source emissions, but they don't have a regional storage solution for that. So trying to really kind of play into what Martyn said about getting everyone into the sandbox and collaborating, getting CO2 emitters coupled up with CO2 stores and kind of transport and storage development companies. So that is where we see the main scalability. In terms of replicating, it's something that we can actively look at within Pilbley Dot and Storeg, our parent company, around where internationally is there also a good CO2 storage potential near existing infrastructure with an industrial site at a beach, and North East Scotland is not the only place with that. Teesside is not the only place with that. To kind of look at where we can essentially export the model of what we are trying to build here elsewhere around the world, and hopefully reduce the costs every time we do it by having increased lessons learned.
Okay, and I think particularly that issue of trying to support those areas where they have the demand for industrial emissions to be captured, but they don't necessarily have the geology that's favorable for them, is really important. It's very telling in the UK, pretty much anywhere south of the Mersey. There's lots of industrial activity. There aren't necessarily natural stores. And then across the rest of Western Europe, there are major economies like Germany, massive emissions and the scope for that to be captured, but not necessarily the geology or the will at a governmental level to see that being stored locally, but conversely quite a lot of will to see it transported elsewhere and across the North Sea and stored elsewhere. So yeah, I think that's going to be a really important part of this, and something that NECCUS is keen to do, is to see that conversation as to how we put in place the standards around how you ship both CO2 and hydrogen internationally and at large scale is something that I think we are keen to see more work done on, both in the UK and Europe, but globally ultimately. Mm-hmm. We're very pleased that Susie's managed to join us, managed to resolve those teething technical problems. Suzie, we'd previously been talking about the importance of new technology, and I really wanted to step back and touch on, the fact that Wood is one of those organizations that's constantly developing new technology and new IP. So within the wider Wood Group, are there some areas that you're particularly excited about that you've been developing or about to develop, without obviously breaking any confidentiality agreements?
Absolutely. Thank you. Can you hear me okay?
Can hear you just fine.
That's brilliant. Phew. Yes, there are. So my job directly involves doing a lot of technology evaluation for other people, looking at novel technologies. For example, if somebody like the UK government wants to make sure they're spending their innovation funding well, then we do due diligence for them on novel technologies that might even still be at lab scale. But elsewhere within Wood, my colleagues get to do that for themselves. So we've got a very dynamic team who are working in hydrogen production. So we've been building hydrogen plants that make hydrogen from natural gas or refinery fuel gases for about 60 years, and we've got 120 plants installed worldwide. But of course, those plants come with a really heavy carbon footprint. Around 10 tons of CO2 is emitted per ton of hydrogen that you make if you are just trying to make hydrogen and you're not part of a climate change abatement project. But that's not where the world is going anymore. So for the last few years, that group has been developing very hard to make sure that they can inherently capture the CO2 that is generated in the process of steam methane reforming. But the same team have simultaneously also been looking about, well, what if we take that blue hydrogen scheme and instead of feeding it with natural gas, we can feed that with a biogenic feedstock. So our reformers are pretty flexible, and they're able to take feedstocks that are even as heavy as naphtha, which means they can take light liquid feeds. So if you're able to find a genuine biogenic waste stream or co-product stream from somewhere else, which doesn't come with a heavy carbon footprint, so it has to genuinely be something that otherwise would be a low carbon sustainable feedstock. Something like glycerol, that's a byproduct from making biodiesel, is a perfect example. You can feed that biogenic liquid stream to one of our reformers with CCS, and you've got the potential to make carbon negative hydrogen. So obviously the scale of these technologies is dependent on assuring you've got a genuinely sustainable feedstock, but there are real markets for this, and it could be absolutely huge, and it's really exciting. So that's my favorite one for now.
Okay, that's excellent, and that actually leans into something that we were also talking about earlier, which is the exciting potential around CO2 utilization, and that's an example of one of the areas where that could go. I also understand that you've been doing some work looking at a CO2 utilization demonstrator in Scotland, in the Grangemouth area. Any thoughts on how that is something that could ultimately lead to technologies that could be scaled up and replicated across the globe?
Absolutely, yes. I mean, when we've looked at early work, we've seen that the scale of the amount of CO2 that we need to capture to mitigate climate change is orders of magnitude above the current scale at which CO2 is utilised. So the UK uses around 1 million tonnes per annum of CO2 for things like the food and drink industry. But there's lots of other places that you can utilise CO2 as well. And how those markets develop is really still remains to be seen. So they could be significant and scalable. So we've been working with Falkirk Council, who are developing a sustainable campus and CO2 utilisation demonstration plant. It's very concept stage at the moment, but it's developing quite rapidly, and we're moving on to the next stage now. And the campus is going to be a location where projects that are looking for the next scale up above lab scale can demonstrate at like early commercial scale, depending what kind of technology they are. And they're really varied, the technologies that have been coming forward and demonstrating their interest in building a plant at that site, which would be near Grangemouth. And that's all sorts of things from vertical farming installations through to very fine chemicals that can be used in the dyeing and production of dyes, as well as for pharmaceutical uses. So there's a huge range of different things. So I really think there is potential there, but it's very much remains to be seen what scale those could come to and whether or not they could make a really significant impact on the amount of CO2 that has to be sequestered. I think it's still really a question. It's something we should absolutely look at to develop and keep an eye on, but I don't think it's going to solve our problems for us. So we need definitely to look at all of the solutions for capturing CO2 and keeping it out of the atmosphere.
No, I think that's true. It's a fascinating topic, but it's part of the solution, not the solution. And sometimes we like to simplify these things by thinking about that there's one solution for all, and that rarely is the case. So maybe a last set of questions, if I could. And for us to deliver net zero, we need to do that in a just way. It needs to be just for society, for the economy, for the environment, and for industry. I'll maybe start by asking a question to Charlie. I mean, Charlie, you were a member of the Scottish Just Transition Commission. That was the first of its kind in the world in terms of a formal commission to look at this topic. So, from that experience, what does a just transition mean to you, and maybe out to the SPE membership? How do you think they could harness their passion to deliver sort of a positive good in this regard?
Yeah, that's an excellent question, and it was a real privilege to serve on the Just Transition Commission. I think one of the key learnings, and it's something that we're quite guilty of in this particular community, in the kind of industrial and energy community, is that the just transition is all about us, and keeping people who work in oil and gas or in energy intensive sectors in jobs. And the reality is that it's so much more than that. It's how we transition the entire economy to net zero in a way that is fair and sustainable, and in particular that is kind of participatory, and it really brings everybody as part of the process instead of kind of doing the transition to some people, which we saw with the likes of kind of the shutdown of the coal industry in kind of 70s and 80s. So I think in terms of where the opportunity really lies for this sector, having said that it isn't all about us, is to think about all the skills and things that we have learned as an industry and how not only we can apply it to the transition rapidly for us in energy, but also to, you know, transport, buildings, agriculture, food and drink, like to really think about, to get away from this mindset that we're all in silos, which I think in particular is quite easy to get in when anything has anything to do with receiving government support. It's often which kind of government department does it fall into, but really thinking about just transition is much more cross-cutting, and seeing where, you know, an organization who has like inherently always worked in one particular area or one particular kind of niche in the sector, are they developing something that can be applied somewhere completely different in order for all of us to reach our net zero target, and ultimately to not do so in a way that makes things worse, deepens inequality, increases poverty. Like the just transition is so much more than energy. It's about kind of bringing everybody along and making a better society that we all want to live in, even more than the one we're in now.
Oh, here. And I also think that it's, you know, it things like the Just Transition Commission brings home just how complex an interrelated society is today, and therefore there could be unforeseen consequences. You know, you make a change, you know, for a positive good, and it has that good, but there is unexpected changes that maybe aren't as positive. I'll come to Suzie again if I could. You know, Wood's done more than many to reposition itself away from traditional oil and gas and towards net zero solutions. How's that journey gone for Wood, and what does a just transition look like from your perspective?
That's a really interesting question, thank you. So I'd say we're definitely still on that journey, and we're going to be a long time taking all of our clients with us as well. So that's one of the things that I'm really passionate about, is we're a really huge company, but we're changing very, very quickly. And we've got some really exciting targets on how much of, you know, they don't sound exciting when they're announced, but how much of our EBITDA we're going to make sure has come from energy transition projects by a certain date. But the things that I find the most exciting are things like we're developing a Wood Energy Transition Academy. So this is to make sure that we don't leave behind those engineers who might feel that their skills in the distillation column design aren't useful for the energy transition. So showing them that actually we're still going to need their skills, and they're only going to need a few hours of training on what to look out for CO2 and hydrogen, instead of looking at your refinery systems in a different way and how you need to incorporate those into the LP models of the future. But also when we get involved in the projects that really have a much more community impact. So we've recently been working on things like energy management plans for some of the Scottish Islands, and things like how can you make sure that the community is involved and has a real community benefit to projects. For example, that would be using renewable power to generate green hydrogen to provide a molecule for heating homes when previously they've been entirely dependent on electric. And some of those solutions can also really help with ensuring that nobody is left behind in terms of the energy transition. Now, it's all very well for, and it's absolutely vital as well, that individuals make as many choices as they can that will mitigate climate change. But there's many people who can't afford an electric car, and they can't afford to have a heat pump fitted in their homes. So some of the solutions that we're looking at with SGN, for example, where you would convert the entire network from natural gas to hydrogen over a staged period, and that includes investing in hydrogen-ready boilers and doing the transition for people in their homes. Make sure that those people aren't left behind with a natural gas boiler that eventually just gets turned off in 10 or 20 years' time. And I think those are the projects that for me are the most, I find those the most rewarding. Okay.
And I think, you know, it's telling. We often focus on urban solutions and industrial solutions, but there's still more of the world that is remote, that is rural, than there is sort of highly urbanized. Well, we're nearly out of time. It's always the way when you talk about things that we're passionate about. One last very brief question, therefore, to each of you. You know, maybe one sentence answer. So, you know, if you had that magic wand and you could change one thing to allow CCUS and hydrogen to develop faster, what would it be? Charlie?
Business models.
Business models. Excellent. Yeah. Get them in place, get them understood, then we use them. Understood, exactly. Charlie? That one's easy. Martyn?
New technology. I think there's a lot of capital funding coming up. It's going to be essential we don't invest in today's technology. We're quite ambitious and far-sighted with how we invest our sort of limited capital. So no surprise, but for me, it's technology.
Excellent. And finally, Suzie.
Well, you said it was a magic wand, so I'm going to invoke the magic element by saying we can magically share all of the information we have about all of the great technologies and projects without anybody stealing that information and using it for their own purposes. So if everybody was able to completely work together with no barriers, no problems with competition law, then I think we could get there magically quickly.
Wouldn't that be nice? Wouldn't that be? That's a lovely thought to leave it on. With that, it just means for me to thank so much Suzie, Charlie, and Martyn for their time today. Thank you for joining us. We hope this was a useful debate, and we hope that you carry on and continue the conversation around CCUS and hydrogen in your own organizations. Thank you. Bye-bye.